In this video, we're going to talk about complex numbers. Complex numbers is a set of numbers that include both the real numbers and what are called imaginary numbers. So a real number is any number that you can measure or any number on a number line. So all the numbers we've talked about up till this point are real. So all of the rational numbers that can be written as fractions, all of the integers that are positive and negative, all the whole numbers, right? All those are in the set of real numbers. So the set of complex numbers includes all of those and all of these imaginary numbers as well. So to form the imaginary numbers, we have what's called the imaginary unit. And we use an I to represent that. So an I, these numbers come about when we take the square root of a negative. So using the I allows us to kind of continue our calculations, and we can do a lot of things with this imaginary unit. So I is always going to represent the square root of -1. It's not a variable, it's what's called a constant, which means it doesn't change. It always represents this. Usually once we've gone from the square root of something negative to the I, it's very rare for us to go back, right? So usually we stick with the I and we write it with I. Another relationship that's important to have kind of in your back pocket is if I were to square both sides. So if I raised I to the power 2 and I squared the right-hand side, the square and the square root and the square would cancel each other out so that I squared is -1. So that's going to come up later, so you want to hold on to that. Okay, when we write a complex number, we usually write it in this form, a plus bi, where a is called the real part. It's just a regular real number. And bi, because it's multiplied by I, is called the imaginary part. And b is still a real number, but it's multiplied by I. Okay, so I always like to take some time to show you how these come about, and then we'll kind of show you where they're going to come up the most and how to work with them, how to add them, subtract them, multiply them, and divide them. All right, so let's start with this example, the square root of -5. Right, just like we did when we simplified square roots, we can break this up, if we would like, as the square root of -1 times 5. And there's a property called the product property that says that we are allowed to break up square root over multiplication. So I can break this into two separate square roots. Here's our square root of -1. So we're going to replace that with an I. And since I can't pull anything else out of the square root for square root of 5, I would just kind of leave it like that. All right, so you try that on this one, the square root of -4. If you want to, you can pause the video and give it a shot. We can do the same thing for the square root of -4. We can break it up as -1 times 4. The -1 is going to be the I, and the square root of 4, we know what that is, right? Usually, if I get a whole number like 2 for the square root of 4, I'm going to write the I behind it. Okay, you could also write the I behind the square root. That's my personal preference, is to write it in front. Okay. All right, so this is just to kind of get us started so you can see the logic for where the I comes from. But from now on, anytime we see the negative under the square root, we're just going to automatically bring out the I. We're not going to go through these steps every time. The place where you're going to see this most is when you're solving with an x squared, and you're maybe using the quadratic formula, right, that kind of looks like this. So I thought I'd give you a couple of examples that kind of matched up with that a little bit. Okay, so what we're practicing here is the square root part. So what is the square root of negative 100? Well, the square root of 100 is 10. And the square root of this negative, right, that's the I. So the I comes out as well. For a fraction like this, the 2 is going to divide into both parts. Right? You could break it up if you wanted to. I guess I'll go ahead and do that. So if you were to break it up, this would be like 6 over 2 plus 10 over 2i. 6 over 2 is 3, and 10 over 2 is 5. So you'd be left with 3 plus 5i. This is that a plus bi format that we were talking about. Okay, let's do the same thing for this one. Oh, I goofed here. This is supposed to be a negative 50. Sorry. Oops. All right, so if I have a negative 50, what can come to the outside? This one's not a perfect square, so I'm really pulling out all your square root skills. Okay, think of negative 50 like negative 25 times 2. If I take the square root of negative 25, that's going to give me 5i. And the 2 is not square rootable. It's not a perfect square, so it stays inside. Just like with this one, right? This 5 is going to divide into both parts. Anything outside the square root, it can divide. You could write it broken up if that's easier for you, or you could just remember to divide both. It's going to end up with 4 minus I square root of 2. Okay, same thing here, right? You could put the I in the back if you like. This is A, this time it's minus, here's our B, I. All right, let's take a look at some of the operations with complex numbers. Adding and subtracting, really we're going to treat the I almost like a variable. It's not a variable, it's a constant, but it kind of acts like a variable. And so we're going to combine like terms. So this is going to look really simple. Okay, so if we're subtracting, we do have to distribute the negative. So that becomes 2 minus 7i minus 1 minus 2i. The 2 and the minus 1 here, we're going to collect those together. They're alike. And minus 7i and the minus 2i, we're going to put those together to make minus 9i. And same here, is in that a plus bi format. Okay, if we're going to multiply, I've got a couple of problems here, right? This one, number 37, we're just going to multiply these two together. So negative 4 times negative 5 would be negative 20. Think of I like a variable. I times I would be I squared. Remember we said since I is the square root of negative 1, I squared is negative 1. So we're going to put that in here. Basically, when I have I squared, it's going to change the sign of the number that it's multiplying by. So this makes this a positive 20. Okay, if I have two complex numbers that are in that a plus bi format, so they have a real part and a complex part, or imaginary part, I'm going to need to use FOIL. So we'll FOIL this together just like we've done in the past. 3 times negative 1. Outside, we'll have 15i. inside we'll have negative 2i, and then 2i times 5i is going to give us a plus 10i squared. These two middle terms we can combine. And just like in the last one, I squared is negative 1. So it's going to change the 10 to be a negative. Once we've done that substitution for I squared, now we have two real numbers, negative 3 and negative 10. So we can go ahead and combine those together. So our final answer would be negative 13 plus 13i. And again, notice that A plus BI format. All right, so we've done adding and subtracting and multiplying. The last thing to look at is dividing. To divide, we use something that's called a complex conjugate. So a complex conjugate, really what we is kind of like a pairing. Conjugate is like a pair. And so we'll have the same numbers, but one of them will have a plus and one will have a minus. And these are both conjugates of one another. So the conjugate of A plus BI is A minus BI, and the conjugate of A minus BI is A plus BI. Okay. So the conjugate of 7 plus 2i would be 7 minus 2i. Okay, so that's all great. Why are they conjugates? Here's why, right? Something special happens if we multiply them together. So let's multiply 7 plus 2i by 7 minus 2i and see what happens. This is sort of like that difference of squares pattern here, right? So we'll have 7 times 7. On the outside, we're going to have minus 14i. On the inside, we're going to have positive 14i. And then the last times the last would be a minus 4i squared. These middle terms are going to add to 0 and cancel each other out. This will be 49 minus 4 times I squared is negative 1. So really that's like 49 plus 4, or 53. Okay, so the thing to point out is that we got a real number as our answer, right? We took two complex numbers and we multiplied them together. When they're conjugates, we end up removing the I, right? I don't know if we did this in the square root video or not, but you could also do this with a square root, right? And the I is a square root, so it kind of makes sense that it follows that same pattern. Okay, so we don't really do division for complex numbers. We use the conjugate, kind of like rationalizing the denominator. So to divide, I'll put it in quotes, right? To quote divide, we're going to multiply the numerator and the denominator by the conjugate of the denominator. So we look at the bottom and we find its conjugate, right? So we're going to multiply by the conjugate of 3 minus I, which is 3 plus I, right? This time it just happens to be the same as the numerator. That's not always going to be the case. That's just a coincidence. Let's come down here. So this will be 3 plus I times 3 plus I over 3 minus I times 3 plus I. Right, notice I'm multiplying by the same number in the top and the bottom, just like we've done in other videos. Okay, so now I'm going to FOIL these, right? So I'll have 9. On the outside, I'll have plus 3i, and on the inside, I'll have plus 3i. So plus 6i plus I squared. In the bottom, I'll have 9 plus 3i minus 3i, those add to 0, minus I squared. So that's going to give me 9 plus 6i. I squared is negative 1. On the bottom, 9 minus I squared again, which is negative 1. So I'm going to have 9 minus 1 is 8. 8 plus 6i over 9 plus 1, so 10. And the 10 divides into both, and we can reduce, right? So 8 divided by 10, if I reduce that, I get 4/5. 6 divided by 10, if I reduce that, I get 3/5 I. And I've written in that A plus BI format. All right, well, I hope that gave you a good idea of how complex numbers work. We are going to be using them in the next chapter, so it is kind of important to get at least a general idea for what they are and how to work with them. All right, well, good luck. We'll see you in the next video.